So this is the unstretched configuration of the bar and the spring. Now, how do we solve this? And it's actually pretty straightforward. But just so you know that in the future, if you want to solve this kind of problem, you should choose one of the two possible approaches. So how do you solve this? Essentially, we have 2, 6, and 7.211. You can either assume that this angle is alpha and this angle is beta, or you can assume that this section is length is A and this section is B. You can either use the length or you can use the angle. Now, as we know that for both triangles, they share this vertical length. Therefore, the first approach is to argue that 2 times this angle is alpha. So this will be sine. 2 sine alpha equals to 6 times sine beta, because the sine alpha is this length, and 6 times sine beta is also this length. This length is the same. The second condition you want to use is what? Is to make sure that the summation of this length, which is 2 times cosine alpha plus 6 times cosine beta equals to 7.211. So it's 2 times cosine alpha plus 6 times cosine beta equals to 7.211. This is the first approach. Now, of course, this approach is not advised. It's not recommended for you to use. Why? Because if you get this one out, you're going to get arc sine. That means on the first condition, alpha equals to arc sine of 3 sine beta. Now, if you put arc sine of 3 sine beta into here, you're going to get cosine times arc sine equals to all this. So the whole thing gets very messy. Rather, you should always use the length approach. So what's the length approach? To use A and B. First of all, we know that this vertical length is what? Because of this Pythagoras rules. 2 squared minus A squared must be 6 squared minus B squared. How do we figure that? It's because this length equals to the square root of 2 minus the square root of, equals the square root of 2 squared minus A squared. And the same thing from the other triangle is this vertical length equals to the square root of 6 squared minus B squared. So this is the first condition. And the second condition we know is A plus B equals 7.211. Now, if you do this, first of all, you can get expression of A out of this. You can say A equals to 7.211 minus B. Put it back to here. This becomes 2 squared minus 7.211 minus B squared minus B. This whole thing squared equals 6 squared minus B squared. Now, if you do that, this problem becomes much more easier to solve. So here you can actually find it 4 minus 7.211 is 52 minus 52 and minus 2. So 7.211 times 2, that is 14. So this is a minus, and the other one is a plus 14.422 B. And this becomes minus B squared equals to 36 minus B squared. Now, because we have B squared on both sides, of the equation, you can cancel. Now here you have only one unknown, which is just B. So you can calculate this. This becomes 4 minus 52 minus 36. That is negative 84 equals, move this positive 14.422b from the left-hand side to the right-hand side, or you can simply just say that 14.422b minus 84 is 0. So of course, simply you can find out the value of b from this, and that's 84 divided by 14.422, which will give you 5.82, and that means A is about 1.39 feet. So this is how you can determine the initial position of this A and B before the spring is stretched. So the summary from this analysis is just to tell you that when it comes to choosing either the angle approach or use the length approach, always go with the length. The math will be much easier for you to solve this kind of problems. Now, after this, we can just come back to finish the example 27. Now, just recall that T1 plus ds1. Do we have the change of gravitational potential energy? Yes, because the bar will also experience vertical change. You also have the G1 plus summation of total work 1 to 2 equals T1, T2 plus VG2 plus VS2. So this is our formulation here. Okay. Now, so what is the time one? So this configuration is when T equals T1, when the bar is horizontal. But when the bar is at 30 degrees, we call this at T equals T2. Like that. All right. And so from here, we will calculate the kinetic energy when T equals T1. Now, how do we do that? We have to know that in order to do this, you have to calculate the mass moment of inertia at the point of rotation. So just call it this point O. And that means I naught equals, what is the expression of I naught? What is the value of I naught? It's not at the center of gravity, but it's at the center of rotation for a slender bar. At the center of gravity, we know is 1/12 times total mass times the span square, or L square, right? Now, when it's not at the center of gravity, but it's at the center of rotation, that will give us what? That will give us 1/3 total mass times total length square, correct? For this bar. And remember, it's not at the center of gravity, but it's at the center of rotation. At the center of gravity, Ig is 1/12 times mass times L squared. This is the first example we did in mass moment of inertia. So for this value, I naught, it becomes 1/3 of mass is 50. 50, remember, is not mass, 50 pounds. 50 pounds is a weight quantity, right? So you have to divide weight by 32.2 times the length, and the length will be 6 square. Correct? So this is the mass moment of inertia at the center of rotation. So we will use this to take care of T1 and also take care of T2. So for T1, what is this value? This value is 1/3 36 times 50 divided by 32.2 divided by 3, and that is 18.63. So what's the unit here? The unit is the slope. Square feet. So this is the mass moment of inertia of the bar at the center of rotation. Now what is T1? T1 will be 1/2 of I naught, which is 18.63 times omega 1 squared. Now remember, this problem at t equals T1, there's an angular velocity. So it's not like initially start from rest. The rest position was the position that we determined before. So here, omega 1 is 2. So you have to use 2 squared, which is 4. And this will be T1. What is Vs1? Vs1 is 1/2 of spring constant. Spring constant is 6 times distance squared, or the elongation squared. Elongation is not 4, but it's a 4 minus 2 squared. And this one is easy. So it's just 6 times 2, that's 12.